Okay, so what is a logarithm? Now, logarithms were invented in the 17th century, around Newton's time, Isaac Newton's time, and they were invented by a man called John Napier, a Scottish man. And he invented them to make calculations such as this: 1.56 times 10 times 10.2 to the power 7.9, say. This calculation here, quicker to solve. Of course, nowadays we have calculators to solve problems like this in a matter of seconds. But in the 17th century, to solve a problem like this would be very difficult, and logarithms provided a quicker way to solve questions like this. Like I said, now we have calculators, so logarithms aren't used in the same way now as they were used in the 17th century. Okay, so that they have wider applications, not just numerical calculations, basically. So that's why they were invented, and now, as I said, they're used for different purposes. So exactly what is a logarithm? Well, if we start thinking about powers first, so if I was to write down this power equation, 2 to the power 3, then we know that 2 to the power 3, 2 times 2 times 2 is equal to 8. Okay, pretty simple. Now we can write this in a different format. We can write this as a logarithmic equation. So this is equivalent to, it's the same as, log to the base 2, this is the base number here, to the base 2, of 8 equals 3. So what we've essentially done is we've made the power, the answer, in a sense. 3 here is now the answer to this logarithmic equation. So these equations are exactly the same. They're just written in different formats. So let's do another example. Let's do 5 to the power 2, say, so 5 squared. And we all know that 5 squared, 5 times 5, is 25. And if I was to rewrite that as a logarithmic equation, then that would be log to the base 5 of 25 would equal the power 2. So what we're actually doing when we talk about logarithmic equations is we're talking about an exponential equation or a power equation written in a different format. Now let me give you another example. Let's start with a logarithmic equation. So for example, if I started with log to the base 10 of 100. Now what's that equal to? Well, some of you may already realize what that's equal to, but let's say you didn't know, you weren't sure. And you could say that that was equal to x. Okay? And you could then rewrite this logarithmic equation as a power equation. Okay, so the base 10 to the power x is equal to 100. And now you might be able to see what the answer is, what x is equal to, because 10 squared is 100, 10 to the power 2. So log to the base 10 of 100 is actually equal to 2. We can do some slightly harder examples. So for example, if I did log to the base to the base 25 of 5. Okay, well, 25 to what power is going to give me 5? If I write this as x, and if I change this to an exponential equation, so the base 25 to the power x is equal to 5. Okay, now let's think, 25 to what power gives me 5? Well, I know that the square root of 25 is 5. Okay, and the square root of a number can be written as a power. So instead of writing the square root of 25, I can write 25 to the power 1/2 equals 5. Okay, so the answer to this logarithmic equation here, log to the base 25 of 5 equals 1/2.